thing that's very interesting, and again, understand a lot of it is going to be me making very bold assumptions. I'm going to ignore a lot of things, which you may or may not be able to ignore in your future life. Ready? Okay. It is called
Bernoulli.
Have you heard this name before?
Yes.
What did he do?
He raced against Lightning McQueen.
Francesco Bernoulli. Yes. Wrong Bernoulli, but good idea. Yes. Yes, he spent, yes. So that is a good way of remembering it. What was he known for? He was known for writing an equation, which is a very important equation. Most of fluid flow stuff is based off of what he wrote, and we're going to develop it. So he said, what are all the things that are possibly could change when you go from point 1 to point 2, and you're talking about pipes?
Pressure, velocity.
Lots of things could change, but what he said was these are the 3 main things that change when you go from point A, any point A to any point B in any pipe. Do you want to hear them?
Yes.
So as you go from point 1 to point 2, let's call this point 1, let's call this point 2. What are all the things that can change? Well, the area can change. So let's say I call this area A1 and this area A2. What else changes? Obviously the height. From H1 to height H2. And we looked at equation of continuity last time. Anyone remember what it looked like?
Velocity.
Equation of continuity says what? A1 V1 has to equal A2 V2. That means larger area, smaller velocity. Smaller area, larger velocity, right? So the other thing that could change with area is
Velocity.
velocity. And yes, also pressure difference. So pressure can change. P1, pressure P2. What else can we think can change?
Temperature.
Temperature could change. Yes, temperature could change technically, but I'm going to ignore that. Hopefully, I'm only going from the first floor to the second floor. Hopefully, it won't change that much temperature. But you're right. Larger areas will change, definitely change temperature. Okay, what will not change? Good. The type of liquid hopefully will not change from point 1 to point 2. Also, one other thing. True, density should not change.
Material.
True, all of those things. One thing I'm looking for. When we talk about conservation, do we also talk about conservation of mass?
Yeah.
If there is mass M1 at point 1, how much mass should be at point 2? The same mass. So mass should not change. Now, the rate at which the mass changes, that can change, right? Because it'll get faster. So it'll go through a particular area faster, right? That we understand. But the mass itself will not change unless there is a hole that either adds more mass in the middle or takes away mass, right? When it adds more mass, we call it a source. When it takes away mass, we call it a sink. Okay, so those are the only 2 ways for masses to change. We talked about this before. Remember when we were doing our tubular flow? a tube of flow, we said the mass here should be the same as the mass here. It's not suddenly going to disappear.